Now we are going to discuss the electromagnetic theory of light. Michael Faraday is the first scientist who discovered the interaction between electricity and magnetism. Faraday observed that when a electrical conducting material is under motion in a magnetic field, then an electricity will be induced in that magnetic field. And also he observed that when electricity is passed in a conducting element, a varying magnetic poles will be produced around that electrical conducting material. So there is a connection between electricity and magnetism. Faraday observed this phenomenon. Then, coming to the theory of electromagnetic waves, in 1873, Maxwell shows that the speed of electromagnetic wave is a constant, or velocity of EM wave is a constant. Velocity of EM wave is a constant, and this value, constant value, is same as the velocity of light. Same as the velocity of light. And he also predicted that, Maxwell also predicted that, then light will be a high frequency electromagnetic wave. Light is a high frequency electromagnetic wave. Then in 1887, Hertz experimentally confirmed the Maxwell prediction of electromagnetic theory of light. Hertz is the scientist who experimentally proven So Hertz is the scientist who experimentally proven the prediction of Maxwell. But they explained that light will travel, or electromagnetic waves will travel in the velocity of light through a medium which is composed of or completely filled of ether. That was the ether hypothesis experiment. And first, in ancient years, the scientists were thought that the complete universe is filled with some material called ether, and the electromagnetic waves are traveled through the ether medium with the velocity of light. Then the main disadvantage of this electromagnetic theory that was it fails to explain the emission and absorption spectrum of some materials or some systems. This emission, or we are familiar with black body radiation and black body emission spectra and some absorption spectrums, and this electromagnetic theory fails to explain the emission and absorption spectrum. Going again, the Michelson and Morley experiment. It is a famous experiment in physics. They experimentally confirmed that there is no such ether medium present in the universe. These electromagnetic waves are moving with the velocity of light through vacuum in universe, and light is considered as a self-sustaining high-frequency electromagnetic wave. Light is a self-sustained high-frequency electromagnetic wave. Self-sustained high-frequency electromagnetic wave. For explaining the emission and absorption spectrum, the next theory of light, the quantum theory of light, is proposed. Quantum theory of light. Quantum theory. We are all familiar with quantum. Quantum is nothing but the units or packets of energy. Some discrete tiny amount of energy is termed as quantum. In quantum mechanics, the energy transfer is quite discrete, quite in discrete way. Then the transfer of energy is carried out by using some packets of energy, and these packets of energy is called quantum. Then the studies and observations of emission spectrum of different objects leads to some new breakthroughs. So in 1900, the famous scientist Max Planck found that it is necessary to suppose that light is absorbed or emitted as elementary quantas. Max Planck found that it is necessary to suppose that light is absorbed or emitted as elementary quanta. So, according to the Max Planck theory, the propagation of light is not a continuous manner or some continuous propagation phenomena, but it consists of some discrete amount of energy is transferred through vacuum, and the velocity of transfer is the velocity of light, and these small packets of energy vibrates with high frequency, very high frequency. So it is confirmed that the emission spectrum or absorption of light is composed of some packets of energy, and these packets of energy is called quantum. Max Planck proposed this explanation by observing the black body radiations. So Max Planck obtained that light consists of some discrete amount of energy, Now in 1905, Albert Einstein used this Max Planck's theory of quantum theory of light for explaining the photoelectric effect. Photoelectric effect. We are all familiar with the Einstein's explanations of photoelectric effect, and also Einstein was awarded by the Nobel Prize for explaining such these phenomena of photoelectric effect. And the Einstein explanation is completely based on the Max Planck's quantum theory of light. According to Einstein, light is considered as a stream of photons which have definite amount of energy. Light is a stream of photon having some definite amount of energy. And if we are considering a single photon, then that single photon is consisting of a bundle of electromagnetic radiation. A single photon is a bundle of electromagnetic radiation moving with velocity which is equal to velocity of light, and this electromagnetic radiation oscillates with very high frequency. Then each and every individual photons consisting of a definite amount of energy as well as a definite amount of momentum. Then this single photon, we can consider that this single photon has some particle nature, because each photon have a definite amount of energy and a definite amount of momentum. So this single photon has a particle nature. But when a number of identical photons or a very large group of photons are traveling through a medium, then this group of photon will exhibit the properties of a continuous wave with some definite frequency, or this continuous motion of electromagnetic radiation will produce a continuous wave and it consisting of a definite velocity and also have some definite very high frequency. So concluding these four theories, that is corpuscular theory by Newton and wave theory by Christian Huygens and the electromagnetic theory of light by Maxwell, and the quantum theory of light by Max Planck, we can combinedly say that some properties of lights are wave dependent and some properties of light are particle nature dependent. So according to the quantum theory, we are familiar with de Broglie hypothesis, and de Broglie suggested that or massive particle with moving with definite velocity will wave or associated with some definite matter wave, and the velocity or wavelength of that matter wave corresponding to lambda is equal to h by p, where h is Planck's constant and p is the momentum of that moving particle. Similarly, here we are suggested that a single photon have a particle nature as well as a group of photon or very large number of photon will produces the property of a continuous wave. Light can be considered have a dual nature. That means light have some particle nature as well as some wave nature. Then the some properties of light are purely explained on the basis of classical wave theory, as well as some properties are explained on the basis of the particle nature of light. That means some properties of light such as interference, diffraction and polarization, as well as propagation of light, propagation through some medium, is explained successfully by using classical wave theory. Similarly, the property of light as a reflection, a refraction and rectilinear propagation of light is can be explained by using the particle nature of light as well as the wave nature of light. But the property of interaction of light with matter, that means mainly the photoelectric effect is successfully explained by using the particle nature of light. Or when we are concluding, we can say that the quantum theory, which consisting of the particle nature of light as well as the wave nature of light, can explain all the phenomena of light successfully. We are familiar with very much different varieties of source of light sources. Then these light sources will produce incoherent waves, or the waves which may not be monochromatic and also not in phase, in a definite phase. So some coherent light sources or some coherent light waves are produced by using the technique of laser, where laser is the light amplification through stimulated emission of radiation in 1960s, and these lasers will produces monochromatic as well as coherent waves, and these laser waves are responsible for production of holograms and optical fiber communication systems. By this, I am concluding the introductory sections of optics lecture. Thank you very much.